Hi, myself Manish, and in the previous video of this PyTorch recitation, you have seen that what are tensors and what is PyTorch and how do you create tensors. In this section of this recitation, you'll know like different operations to do on tensors and why are they necessary because of what when you're passing tensors to the model, what you have to do is like you have to reshape the tensors because the input shape might not match with the shape of the input which the model requires. So the first operation here is flatten. So what the flatten does is like it changes a multidimensional tensors to a single dimension. So let's take a look at an example. Here you can see the original tensor is of size 3, 4, 5. When we flatten this tensor, what it does is that it collapses the other dimensions and reshapes every element of this tensor into one dimension. So here you can see the original shape of this tensor is 3, 4, 5. When we have flattened the tensor, it's now 60 because 3 times 4 times 5 is 60. The next operation here is squeeze and unsqueeze. So let's take a look at what unsqueeze does. So here we have an original tensor of size 3, 4, 5. So let's say if I want to unsqueeze something. Unsqueezing is basically like increasing dimension along that particular axis. So when we have mentioned it's 0, what it does is that it increases the dimension before that particular axis. So here you can see the original dimension of this tensor is 3, 4, 5, and when we have unsqueezed the tensor, its shape is now 1, 3, 4, 5. And when we do this again, then you can see that it has increased one more dimension. So you can repeat this procedure as many times as you want. Now, if we have unsqueezed the dimension along a different axis, unsqueeze the tensor along a different axis, let's say the axis was 1, then what it does is it increases a dimension before that particular axis. So here you can see the dimension of this tensor is now 3, 1, 4, 5. Next is squeeze. So squeeze is the opposite of unsqueeze. What it does, it collapses a dimension along a particular axis. So here you can see that what we are doing is like squeezing along the axis 0. So previously the size of the TS sensor was this, but we have unsqueezed it along the axis 0, and now we have this uh, tensor to 3, 4, 5. And we can do the same thing along different axes. The next operation is reshape. So reshaping is something like changing uh, cha changing the element of the tensors into a different shape. So if we have a tensor of size say 3, 4, 5, then there are like 60 elements in it. So we can reshape it in different shapes. So one shape could be like 12, 5. So rearranging those elements to in this shape. So here you can see that there are like 12 elements, 12 elements in the first axis and 5 elements in the second axis. So total it's 12 times 5, it's 60 elements. You can also call the same operation by putting -1. So you can also like reshape in different forms, like for 5 comma 4 comma 3, and when you just put -1, what it does is just reshapes into only one dimension. So it collapses multiple dimension and just rearranges every element of the tensor into just one dimension. So here you can see the size of this tensor is now 60. The next operation is view. View works similar to reshape. The only difference is that view only works on contiguous tensors, whereas reshape works on both contiguous and non-contiguous tensor. So you can know more about contiguous and non-contiguous tensor through this link. The next operation here is transpose. So let's say we have a tensor of size, say 2 comma 3 comma 4. So what transpose does is it flips the element of a tensor along those axes mentioned. So here we have mentioned axis 0 comma 1. So what this will do is just it will place the elements of the zero dimension into first dimension, and the elements of the first dimension to the zero dimension. So here you can see that when I have reshaped transposed it to 0 comma 1, then the axes have changed from 2 comma 3 comma 4 to 3 comma 2 comma 4. And we can also do this with other different axes like 0 comma 4. So now you can see the axes to 2 and 4 have flipped their positions. The next operation is permute. So you have seen the transpose operation. So what permute does is that you can actually flip multiple dimensions at once. So transpose only does the flipping operation like for 2 dimensions only, but for permute you can actually flip multiple dimension like 3 more than 2. So here what I'm doing is that we are flipping the dimensions or changing their positions in this manner. So now we have the elements in the first axis in the zeroth place, and the elements of the zeroth place in the first place, and the 2 is in its original place. So here you can see like I have flipped it from 2 comma 3 comma 4 to 3 comma 2 comma 4, and likewise you can do 1 comma 2 comma 0. Next is the additional tensor operations. These are really important when you are doing some operations when you are passing the input. So let's take a look at what concatenating tensors mean. So here we have like 4 tensors of different sizes. So when I'm concatenating like 2 tensors along a particular dimension, say 1, so what I'm doing is that I'm actually stacking those 2 tensors along a particular dimension. So here you can see these are the 4 original tensors. And when I'm concatenating the first two tensor along the axis 1, what it does is that it stacks those two tensors along that particular axis. So the first two tensors were of shape 2, 3, 4. What it did was that it just adds adds the element in the dimension and stacks them. So here you can see the shape is 2, 6, 4. And likewise, you can do it for other dimensions as well, like stacking in different dimension along different dimension. So the next operation is the tensor stack. So you have seen the previous operation of concatenating. So this stacking operation is something combination of unsqueeze and concat. So what this does is that it adds an additional dimension as well as concatenates it. So here you can see the original. Here you can see the original tensors are these. So it it stacks the two tensors, but also adds an additional dimension to the tensor. So 3, 4 and 3, 4 get stacked to 2, 3, 4. So if it was only the concatenating part, this would have been a different, this wouldn't have added a new dimension to this tensor. Then we can go on to the tensor repeat. Tensor repeat is basically like repeating a particular tensor along a particular axis. So here it's only just a single axis, a single number. So what it does is just repeats the original tensor twice along the row. So when I have mentioned like a tuple of 4, 2, then what it will do is that it will repeat the original tensor along the first dimension 4 times and along the second dimension twice. And likewise, you can do for multiple dimension. So the last operation in this section would be the tensor padding. So tensor padding is something really necessary when you are doing stride. I know the stride is something like you are not aware of it right now, but you'll be aware of it when you go through the course. So it is important to use padding so that you don't lose any information while striding. So here you can see the original tensor is this. So when I'm padding, is what it does is just it adds certain values to the original tensors. So here you can see like I'm padding the left side of this tensor by one value and the right hand side by 2 values. So here the original tensor is this. So what I did was I added 1 value on the left hand side, added 2 value on the right hand side, added 1 value on top of this, and added 2 value to the bottom of this original tensor. So you can change this value to any number. So currently it's 1. You can also change it to 0. So that's how you do it. And that's all in this section. Thank you for listening.